Have you ever dreamed of having the power to freeze anything like Elsa from Frozone? Making ice and freezing things has always sounded amazing. But how possible will it be to have a superpower like that in real life? And how useful will it be? I'm going to explain both questions, and by the end of this video, you will know how to freeze water instantly. First, we need to understand the basics. When water reaches 0 degrees, it freezes. That means it changes from liquid to solid, forming a crystal network. But the important part is not how it freezes, it's what happens when it freezes. During this process, energy is released. This is called exothermic reaction. Every gram of frozen water releases 334 joules of energy. That means 1 liter bottle of water releases over 300,000 joules. That's about the same energy as a microwave running for 5 minutes. Let's say Elsa from Frozone wants to freeze a person of 70 kilograms. Considering that a person has 60–70% of water, this means is 42 kilograms of water to freeze. That equals over 14 million joules of released energy. And here's the first problem, that energy has to go somewhere. Elsa will have to absorb or release this energy, and if she can't, then she will die immediately. It's like playing Call of Duty Warzone on Nintendo Switch. That means if Elsa freezes everything in her path, she might drop dead on the spot. Thus, it could be solved with a material called graphene. It's stronger than steel, light and flexible, and is also one of the best thermal conductors on the planet. This will explain why Frozone from The Incredibles is always looking for his suit. Just think about it. It might be made of graphene. He already has the superpower, but he needs technology to not die when using it. And a graphene suit will explain how he survives. Speaking of Frozone, he freezes things in seconds, but in real life, when something freezes, it releases energy slowly. That's why a water world takes hours to solidify. If Frozone existed in the real life, it will take him ages to solidify to make ice someone. And to be honest, I cannot imagine the bad guy waiting a lot of time just to be converted into a popsicle. However, there is a real phenomenon called supercooling. That's when water stays liquid below 0 degrees down to -38. And when a particle or bubble comes into contact, it instantly forms ice crystal. That is instant freezing. And with that said, at the end of this video I'll tell you which ice power character will be most likely to exist in real life. But tell me in the comments first, who do you think it is? Back to instant freezing. This is where a real bacterium comes in, Pseudomonas syringae. It produces a protein called IMP that can induce ice formation. It makes easier and faster to freeze the water. If Frozone were real, he'd need to have this protein. That way, producing ice wouldn't require as much energy. But he'd also need to live in a cold place for it to work. And energy is not the only problem. When you freeze something, ice expands. This happens because water molecules form an hexagonal crystal structure. So, if you freeze the inside of an object or a living being, the increase in volume causes internal pressure that could rupture cells, organs, and tissues. Rather than just freezing people, Frozone will make them explode from inside. But some animals don't die when they freeze. How they do it? Tardigrades, or water bears, are microanimals that are less than 1 millimeter long. They are famous for being nearly indestructible. They can survive temperatures of -272 degrees. They do this by entering a state called cryptobiosis, where they suspend almost all metabolic activity. They also produce special sugars that replace water in their cells, and proteins that act like biological glass to protect their DNA. There are also insects and fishes that can be frozen thanks to special proteins. So maybe Iceman has this kind of molecules that protect him when he turns into ice. And what about freezing objects or the environment? Honestly, you can only freeze things that contains water. Otherwise, it's impossible. For example, if Sub-Zero used a frozen sword, it will break into pieces because ice is very fragile. But Sub-Zero has a trick. He can form a morphosize, a type of ice without crystals that is stronger and more resistant. But if he doesn't keep it in a controlled environment where he manages all the variables, this kind of ice wouldn't last more than a few seconds. Ice power characters always freezes the environments, but for that to happen, they need to freeze the air. Air is mostly composed of oxygen and nitrogen. To freeze them, you'd need to lower the temperature way more than for water. So, to freeze a forest or lake, you'd have to reduce the temperature so much that everyone there will die. And no matter how cool these scenes look, they are not realistic. So, which of these 4 characters could exist in the real world? All 4 could exist if they meet these conditions. Have proteins that accelerate ice formation, like those in bacteria, have proteins that protect them from freezing or help them to survive, live in a very cold environment, use a suit or system to release the energy, like graphene. But the most likely character, based on what we know, is Elsa. She produces ice quickly, so maybe she has these fast freezing proteins, and maybe she also has these protective proteins. She already lives in a cold environment, and maybe her dress is made of graphene. Now, who will win in a fight between these 4? That's another history. Ice power sounds epic in video games and movies, but in reality, it's a nightmare. You need extreme temperatures, absorb heat, prevent fractures, protect yourself. In other words, it's the most useless superpower of all. If you'd like me to analyze another superpower and see if it will work in real life, tell me in the comments. If you liked the video, like and tell me in the comments which superpowers you would like to have. Also, check out my video about the walls of Game of Thrones and how they were revived. See you next video.